Welcome to the module on Rock Fill Embankment. Today in this module we will be discussing about the embankment in general, what is the definition of embankment, and Rock Fill Embankment in particular. What is embankment? We call it embankment is required for roads, railways, canals, and is raised onto an embankment made of earth to avoid the change in level. That means if you see the photograph, we have a road which is having an FRL, that is finished road level at this level. Now you have an existing road also which is crossing the new road from the below. So you have to elevate the section at this location in order to make free the movement of vehicles from both directions. Now, when you want to raise your construction level from one level to other, you need to increase the height of construction. But since your crust thickness is fixed, we call it crust thickness, which will be defined in the upcoming slides. What is a crust thickness is. Generally the crust thickness for any road is fixed. So if you change the levels, the finished road levels as compared to the original ground level too much, then the variation needs to be adjusted using an embankment only. That is what exactly we are trying to explain, the importance of embankment and how the embankment material can be divided into different layers. Say this is the cross section of the road. Okay, and this is your original ground level. We call it as OGL, and this is your finished road level or FR. This is your center line. So this is basically the cross section of the road, and then this is the crust thickness. We call it as CT. Say H1, and then you have a subgrade which is generally 500 millimeters thick. So the remaining portion, if you make it in different color, so the remaining portion which is being highlighted in the figure is basically your embankment, which is being constructed in layers starting from the bottom. So 1, 2, 3, 4, 5. Each layer is having a minimum thickness of 250 millimeters. Not minimum, it is the maximum. It has to be the layer wise compaction of 250 mm thick layers. So if you want to calculate the height of the embankment, it is the difference in level between the FRL and the OGL, which will be giving you the total height. Okay, so if this is your total height, capital H, minus H1 minus H2 is your subgrade height. Okay, so this will give you the embankment height, which is called EH. This is how we can calculate the height of the embankment. Embankments are constructed using suitable materials to provide adequate support to the formation and long-term stability. If you see the photograph, this has been shown both from left side as well as from the right side, and you can see the difference in level. This is your FRL and this is your OGL. So this is the vertical height which is needs to be countered or filled to raise the original ground level to finished road levels. Embankments are often constructed using materials obtained from either the cutting sections or the borrow areas where they are identified based on the soil properties they have. If you see the photograph, this is the construction phase. This is the construction phase which indicates that the soil is being laid in this section, okay, which has been watered using a water tanker. So this is required to maintain the optimum moisture content of the soil. And then you have another equipment which is called the grader. Now this is the front side of the grader and this is the blade of the grader, okay. So the blade can be tilted and arranged in such a way that it can help to mix the soil and do the necessary pulverization and maintaining the camber and the levels. Now coming to the Rockfill embankment. Embankment constructed using the rocks of size 300 millimeters or less and a layer thickness of 500 millimeters instead of 250 millimeters, constructed to achieve the required FRL, is known as Rockfill embankment. If you see more specifications for rock embankment to be followed, the minimum layer thickness is 500 millimeters, the maximum layer thickness is 100 millimeters against the earthwork, which is 250 only. The desirable maximum particle size is 300 millimeters, whereas for embankment you have maximum as 75 millimeters only. The percent smaller than 125 millimeters shall not be more than 10%. 5 passes of 8 to 10 vibratory rollers will ensure proper interlocking, okay, proper interlocking of aggregates, and then finally the voids formed by the rock needs to be filled with broken fragments of the rock fill materials. Now, minimum height one should have in order to go for a rockfill embankment is the minimum layer thickness of rockfill is 500 millimeters. So generally, for an embankment height of more than say 1 meter on 1.5 meters, rockfill can be adopted. But if the embankment height in total is 500 millimeters, then probably you will not be able to adopt the rockfill embankment. Now, the methodology of Rockfill embankment, if you see, you need to maintain the layer thickness. The maximum layer thickness allowed is 500 millimeters. This is what is allowed as per MORTH. And then the particle, you need to have a control on the particle size. Maximum particle size is 300 millimeters. And then the percentage finer than 125 millimeters needs to be less than 10%. Then the infill materials, the blinding materials can be used for filling of voids, and compaction can be achieved by 5 passes of vibratory rollers having a static weight of 8 to 10 tons. Unlike the soil embankment, you will not be able to measure the level of compaction in case of a rock fill embankment because there is no such test, but the percentage fines provided in the layer will give some indication about the percentage compaction. And then the finished layer after compaction of each layer, after mechanical compaction, that is interlocking of aggregates, the surface voids shall be filled with the broken fragments. If you see the picture of a rock fill embankment to start with, it starts with these particles, which is generally needs to be ensured that the size of the particle is less than 300 millimeters, and then after finishing it, laying it, you will have to fill it with the fragment particles, which is 125 mm, and then the it being rolled properly to get the proper interlocking of aggregates. Typical cross sections of construction of rock fill embankments is shown schematically using the line diagrams, where you can see the highlighting positions, like this is your original ground level, then you have the rock fill construction as the next layer, the fine particles on top of the rock fill construction, then again putting the rock fill constructions, and then the fine top on the rock fill construction. So this is the step-by-step approach to construct a rock fill embankment, which is required and defined as per MORTH by showing the confinement layers on both sides. So this is your confinement layer on both sides, which is basically a material suitable for confinement equivalent to the subgrade materials if required, but we should have the good PI value. Then on top of the rock fill embankment, you can put a layer of approved soil, which can be treated as embankment soil, and then finally on top of it you make a subgrade layer, which is of 250 layer each, a total of 500 mm thick. So this is the configuration of the rock fill embankment, and the advantage of this configuration is like you have the faster mode of construction, since instead of 250 layer thickness you are allowed to go for 500 mm layer thickness, and you don't have much to do on in terms of the check of compaction and all those things. So this is the typical photograph of the rock fill embankment construction, which indicates that you have the rocks which is being filled, and on top of a rock you have the fine materials which is being laid to pour the gaps or the seal the top of the rock fill embankment, so that it will help the rollers and the other equipments to move smoothly. The best way is to put the fine materials on top of it and then supply ample of water, so that the fines will get penetrated into the rock fill embankment, thereby minimizing the voids, which can be a biggest challenge as far as the rock fill embankment of bigger heights are concerned, because the chances of settlement or the long-term consolidation or the movement of fine materials from top to bottom will be higher when the rock of size 300 mm are being laid in the rock fill embankment. So this is showing the typical cross section of each layer, a combination of rock and fine materials, and then on top of it again rock fill and then the fine materials to seal it, and followed by the confinement on both the sides, and then top of the soil being treated with 2 layers of embankment, and then the final layer of subgrade to close the rock fill embankment construction. How do we check the performance of the rock fill embankment, or how do we check whether the construction of rock fill embankment is meeting the specification requirements established in MORTH or not? For that, you need to have a random check on the working embankment layers. You can collect samples by using the excavator's bucket as shown in the photograph. So this will help you to collect the samples at a defined location for a set size, say 1 meter by 1 meter, to the required depth where the construction of the rock fill embankment is being done, and then take out the material and check for the size of the material which is required to be followed, and then the minimum percentage fines required to be followed. So these are the things which can be done, and then the presence of voids in the rock fill embankment to make sure that there won't be any settlement in the future because of the movement of fines into the voids. The controls required can be shown, like the rock fill is being done. On top of it, you need to have a layer which will facilitate the rollers to move freely, and then do a static compaction on top of it. So the checks for particles finer than 125 millimeters, which needs to be below 10%, is to be done on the samples collected from the bucket of the JCB or the loader or the excavators, and then confinement of the rock fill embankment, which is required in order to make sure that there is no movement of the rock or the infilled soil from the side. Because if you have a rock fill embankment of this, a rock fill embankment filled with rock, and you are also laying, if you are not confining it from the sides, if this confinement is not there, this will have a tendency, these rocks, the particles of the rocks will have a tendency to move horizontally, the fines which can be washed out because of the infiltration of water, and then the voids can be moved. So confinement is a must and is required before the start of the rock fill embankment. What are the key benefits of rock fill embankment? The key benefits of rock fill embankment are: it will help you to understand, it will help you to expedite the speed of work. It will help you to use your existing materials, the rocks which are available, because normally the soil embankments you do at 250 layers levels, where in case of rock you can go for 500 layer altogether, and the particle size is so big. Now, no compaction check is required, only the confirmation of 8 to 10 passes of vibratory rollers, and ensuring the interlocking of the aggregates by proper compaction. Faster mode of construction is a second benefit which is required, and then you have no dependency on the search of the good soil. This is the most important aspect as far as the project is concerned. Otherwise, the lead, because of the requirement of the availability of the good soils, you lose time and money in spend more from different materials of a longer distance, a longer lead, and then increase stability due to aggregates interlocking. So to summarize, this module has talked about the embankment and the Rockfill embankment in general, how to eliminate voids in the Rockfill embankment, under what conditions we should choose a Rockfill embankment, and why it is important to check for voids, if any, during construction. Do subscribe and follow Highway Guru and my website thequalityguru.in to get yourself updated on the changes in the recent technology and the requirements of the standard. Thank you. Thank you very much for sparing your time.